graders, welcome back. We're going to start in on a brand new chapter. We just finished up doing quadratics. We recently took a test, and I hope you did wonderfully well on that and did a great job solving quadratic equations. Now we're just going to kind of abandon all of that, move into something completely different, and now we're in chapter 9, section 1. And our objective, by the time we're done with all three of these examples, we want to be able to recognize and extend geometric sequences. We also want to find any term in a geometric sequence, and we call that any term the nth term. That's what we call that in general. When we're not specifically looking for a particular term, it could be any term, like the 13th term in the sequence or the 20th term, the second term. If we don't know specifically which term we're looking for, we call that the nth term, okay? So let me go ahead and kind of demystify the top part of your notes, because I know that may look concerning to some of you. Position, all that means is when the numbers are in sequence. We are talking about sequences, okay? When the numbers are in sequence, and here is our sequence. I'm going to go ahead and circle that. Our sequence is 3, 6, 9, 12, okay? And so what I want you to see is that the position, the first position, just means that the number 3 is the first number in my sequence. Position 2 just means the 6 is in the second position. The number 3 means 9 is in the third position, and the number 4 just means that the number 12 is in the fourth position. I have to make just a little bit of an adjustment, so if you'll forgive me, it looks like I'm out of alignment, so that should fix it right there. Okay, and we're back at it. We're back in business. Okay, so what may be a little troubling to you is you see these algebraic terms, an A with a little 1 beside it, an A with a little 2, etc. and so forth. All that means is, if you ever see that terminology, and we read it as A sub 1. A sub 1 just means the ones slightly below the A, okay? And all it means, it's the first term in the sequence. A sub 2 is the second term. A sub 3 is the third term, and so on, okay? And so when we're dealing with geometric sequences, what makes them unique is they have a common ratio, okay? And what that is, a common ratio is the number being multiplied to the previous term to get to the next term, okay? So I do want to kind of show you an example here in this space down here, just so you kind of get the gist of it. So A sub n, and this is a formula. I just want to make sure that I tell you, this does not need to be memorized. Don't memorize this formula. You know how to find sequences and numbers that come next. It's unnecessary to memorize this. It's confusing, I know, but I'm going to try and demystify it for you. A sub n, all that means is that's any term you're looking for. That could be like the 10th term in the sequence, the 5th term, the 2nd term, the 80th term, whatever term it is, that's A sub n. And to find A sub n, this is what you need. A sub n minus 1. The n minus 1, all that indicates is it's the number right before the term you're trying to find. That's all it is. So for example, if we were doing, like, let's do 2, 4, 8, 16, 32, okay? That's our sequence, okay? And let's say we're trying to find the next term in the sequence. Well, our common ratio R is the number you're multiplying to the first term to get to the second term. So how do we get from 2 to 4? Using multiplication, of course. And you're right. If you said, hey, I'm multiplying by 2, you're absolutely right. How do I get from 4 to 8? I'm multiplying by 2. How about 8 to 16? I'm multiplying by 2. So you see the pattern. Your R, your common ratio, is 2, because that's what you're multiplying the previous number by to get the next number in the sequence. And so a sub 1, if I was looking for the next number after 32, so this is the number I'm looking for, is this one right here. That's going to fill that spot. To find that number, I would go to the number before it, which is 32, and I would multiply it by 2. What's 32 times 2? 64. That's all geometric sequence is. If you want to find a term, go to the number right in front of that term you're looking for and multiply it by the common ratio. That really is all it is in a nutshell. Okay? So let's get to our next page so I can kind of show you some more examples, and then we leave a couple for you for extra credit. So we're supposed to find the next 3 terms in each geometric sequence. I'll do A and B, and I'll leave C and D for you. Okay, so here's our sequence. 1, 3, 9, 27. So the first thing we're going to do is we're going to find R. Now, sometimes you can just see it right away. You're like, hey, I know exactly what I'm multiplying by. So that's great. Sometimes it's not as obvious, and you may need a little bit of help. So here's the strategy. To find R, you just divide each term by the one before it. Okay? So 1 doesn't have a term in front of it, so we're going to go to the next one. So we've got 3 divided by 1, that's 3. Then we've got 9 divided by 3, which is also 3. And we've got 27 divided by 9, and that's 3. So because they're all being, to get to the next term in the sequence, we're going to multiply by 3. Our common ratio is 3. That's how you find it. You just take a term, divide it by the number right in front of it. And it doesn't matter which one you choose. If you know it's a geometric sequence, and they're telling us these are geometric sequences, then that's how you find it. Okay, now step 2, just multiply each term by R to find the next 3 terms. So let's start with 27. So we already know these 3, or these 4. So what we're going to do to find the next 3 terms, and you don't need a graphic calculator, you just have any calculator, do your computation on the side of your paper, whatever works for you, and just multiply. Start with 27. That's the last term in the sequence. Do 27 times 3, and that's 81. So we'll just multiply by 3. And then we'll do the same thing here, multiply by 3, 81 times 3, that's 243. And then you'll do it one more time because they're asking for 3, the next 3 numbers. And then we'll have 729. So that's the next 3 numbers in our geometric sequence, okay? So find R, and then once you know what that number is, you can multiply it to the last number in your sequence and get your next 3 numbers in a row. Now let me show you B. B's a little different because this time the numbers are decreasing and they're changing signs, which is a little bit unusual. So remember our strategy for finding R. Take the second number, 4, and divide it by the first number, negative 16. Or you can do any of the numbers. You can do negative 1 divided by 4, or 1/4 divided by negative 1. Whatever, it doesn't matter. We know it's a geometric sequence. Just pick 2 numbers in a row. The one to the right divided by the one on the left, okay? So 4 over negative 16, you can turn that, you can leave it as a fraction, or you can turn it into its decimal form, and that's fine. It actually is a little more calculator friendly if you go ahead and turn it into its decimal form. So your common ratio is negative 0.25. So what you're going to do is you're going to take your last number in your sequence, okay, which is 1/4. You can actually mark out 1/4 and actually just call it 0.25. And then find your next 3 numbers. And you would just do that by multiplying 0.25 times negative 0.25, okay? So just multiply. So let's do that, 0.25 times negative 0.25, and I've got negative 0.0625, and you can either write the decimal equivalent, that's fine, that's fine. Or your calculator, if you have your graphing calculator, will turn it back into a fraction for you, and it's negative 1/16. Okay? You guys see how I did that? So, or hear how I did that? It's just using more of your graphing calculator. So, and then take your negative 0.0625 and again multiply it times negative 0.25, and you'll get a really long decimal, 0.015625. Your calculator will turn that into its fraction form for you, and you've got 1/64. And then take your 0.015625, multiply it by negative 0.25 one more time, and you'll get negative 0.00390625. Woo. I almost would probably encourage you to do the fractions. I think the fractions would be easier to write. And then you could also write that as negative 1/256. So notice how every other one is negative. The only way that'll happen is if your common ratio is negative. If your common ratio is positive, then all your numbers will end up being either all positive or all negative, depending on what the first number is. So, but with a negative common ratio, it will alternate positive, negative, positive, negative, positive, negative. Okay? So as promised, I'm going to leave C and D for you to try and find the common ratio, and then please find the next three numbers to complete this sequence. Okay? Ready, set, go. Thanks for listening.